Welcome to my lecture series on GATE Maths. In this roadmap, now we are on the matrices and determinants, and I have completed classification of matrices and algebra of matrices. Those who have not seen this, please check on to my previous video. And now I am going to take about properties of matrices. So just a recap what we have seen. On the classification part, we have completed square matrix, diagonal matrix, scalar, unit, triangular, and a null matrix. And on the algebra part, we have done all these addition, subtraction, scalar multiplication, and matrix multiplication. So what is a square matrix? A matrix which has the number of rows that is equal to number of columns. We call it as a square matrix. And diagonal matrix, only the principal diagonal will have the elements, others the rest will be 0. And the scalar matrix, the principal diagonal elements will be the same. That is 5 means 5, 4 means 4, every remaining will be 0. Unit matrix, the principal diagonal will have 1s. And triangular matrix, upper triangular means you will form the zeros in the down, that is I when I less than j. And the lower triangular means we will form the zeros in the upper side, that is I greater than j is the condition. And null matrix means the matrix that contains 0. Algebra, in addition, subtraction, scalar multiplication, and matrix multiplication, the common thing is addition is commutative, addition is associative, addition is distributive, and cancellation law holds good. And at the same time, for matrix multiplication, it is not commutative all the time. Sometimes it may be commutative, and it is associative. And cancellation does not hold good. Scalar multiplication, when you multiply a matrix with a scalar or addition of matrices with scalar, you can make it with lambda A plus lambda B. In the properties of matrices, we are going to see trace of a matrix, transpose, conjugate, and transpose conjugate. So what is a trace of a matrix? See, consider a matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. What is trace means? The sum of the elements in the principal of the leading diagonal. Sum of the elements means 1 plus 5 plus 9. That is 15. This will be written as trace of A is equal to 15. This is the trace. Hope you understood now. For a unit matrix, I is equal to, unit matrix is always mentioned as I. I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. What will be the trace? It is a 3 cross 3 matrix, right? 1 plus 1 plus 1 is equal to 3. Trace of I is equal to 3. Simply you can write as the trace of a unit matrix will be n. If it is of n cross n order, the trace will be n. Trace of I will be. And another thing, what are the remaining properties in this? That is trace of A plus B is equal to trace of A plus trace of B. This is one property. And another thing is trace of AB is equal to trace of BA. The trace will be same for AB and transpose. Transpose of a matrix is nothing but interchanging the rows and columns of the matrix. Consider a matrix A is equal to 1, 2, 3, 4, 5, 6. And the transpose of this matrix will be A transpose. You have to write transpose as A transpose. A transpose is equal to, now here this is the row 1, 2 and 3. This will become the column here. Column in the sense 1, 2, 3. And this row will become the next column 4, 5, 6. So interchanging the rows and column is called as transpose. And the properties of the transpose is A transpose, the whole transpose is equal to A. And the next is A plus B, the whole transpose is equal to A transpose plus B transpose. Alpha A, the whole transpose is equal to alpha into A transpose. This is alpha is a scalar. So when you are multiplying a scalar and the whole transpose after you have done, you can take back the scalar back and it will become a scalar into A transpose. Next, determinant of A transpose will be the determinant of A. And AB, the whole transpose, will be equal to B transpose, A transpose. This is an important property of transpose. This has been asked in one words. Very important one. AB the whole transpose is equal to B transpose A transpose. Conjugate. This conjugate can be done. Conjugate matrix is when a matrix that has complex numbers 2 plus 1 plus I, 4 minus I, 3 minus I. This is a matrix, and the conjugate matrix can be written as A theta. You have to find the conjugate of this and write A 2 plus means you have to change the sign. 2 minus I, 1 minus I, and here 4 minus sign is there, so plus I, and 3 plus I. This is the conjugate. And here the properties of conjugate is, you will mention conjugate as A bar, and A bar the whole bar is equal to A, the same thing as transpose. If A bar is equal to minus A and A bar is equal to A, this means the matrix is completely imaginary. This means the matrix is real. When A bar is equal to minus A, it is imaginary, and A bar is equal to A, it is real. AB the whole bar is equal to A bar B bar. And transpose conjugate. The same thing. We are combining both the transpose and conjugate at the same time. You have to change the rows and columns, interchange the rows and columns, and you have to change the sign. This is the transpose conjugate. And this is mentioned as A theta. We'll move to the problem. And another property I have forgot to say. AB the whole theta is equal to B theta A theta. This is same for transpose. For a transpose matrix, AB the whole transpose is equal to B transpose A transpose, and AB the whole bar. For a conjugate matrix, AB the whole bar is equal to A bar B bar, and AB the whole theta. This is transpose conjugate means, let A and B be real symmetric matrices of size n cross n, then which one of the following is true? A transpose is equal to 1, A equal to A inverse, AB equal to BA, and AB the whole transpose is equal to BA. So A and B are real symmetric matrices of size n cross n. Okay. A is equal to real symmetric matrix means A transpose is equal to A, and B transpose is equal to B. Now AB the whole transpose will be equal to B transpose A transpose. Now what is B transpose? B transpose is B, and what is A transpose is A. So AB the whole transpose will be equal to BA. The answer is D. For a symmetric matrix, you have to remember this one. For a symmetric matrix, A transpose will be equal to A and B transpose will be equal to B. I'll explain what is symmetric matrix in my next video. It will come under the special matrices. And the next problem, if matrix A equal to 2, 4, 1, 3 and B equal to 4, 6, 5, 9, the transpose of product of these two matrices, AB the whole transpose is the same thing we know, right? AB the whole transpose is equal to B transpose A transpose. You have to find the transpose of B first and the transpose of A next, and you have to multiply these two. So transpose of B is 4, 5, 6, 9. I have written the transpose here directly, and A transpose is equal to 2, 1, 4, 3. B transpose A transpose is equal to 4, 5, 6, 9 into 2, 1, 4, 3. That is equal to 4 2s are 8, and 4s are 4, plus 12, plus 9 4s are 36, 38, 30. Given the matrices J and K, the product of K transpose J and K is 43, 89, 21, and what you have to do? K transpose J and K. That means, what is K transpose? First write it 1, 2, 1. What is the J you have to write as such 3, 2, 1, 2, 1. The K, again you have to write the same 1, 2, 1. Is it multiplication compatible? Check it now. This is 1 cross 3 matrix, and this is 3 cross 3 matrix, and this is 3 cross 1 matrix. You have to multiply these two and you will get a 1 cross 3 matrix. Again you have to multiply these two and you will get 1 cross 1 matrix. Okay. Now when you multiply it, 1 into 3 plus 2 2s are 1 1s are 1 plus 8 plus 2, 1 plus 4 plus 6, writing the same, 8, 12, 11, 1, 12 2s are 24, plus 1 11s are option A. Thank you.